Hello, hello, everybody, and welcome back. We're looking at question 22, our second question in part C, on the 2007 grade 9 Pascal paper. So what have we got? A Safa ran at a speed of 21 kilometers per hour from P to Q to R to S. As shown. So the distance between P and Q is 8 kilometers, then Q and R is 15, and then 7 kilometers for R to S. Okay. Florence ran at a constant speed from P directly to R and then to S. They left P at the same time. Haven't specified that, but okay, they're the same time. We just, it's not like 8 a.m. or anything like that. Same time, and they arrived at S at the same time. Okay. How many minutes after Florence did a Safa arrive at point R? Ooh, okay, so there's a lot to unpack here. Definitely a lot going on. So, we know a Safa's speed, and we know the distance that a Safa went. Alright, so we can figure out the time it took a Safa to get to S. Now, we don't know all the distances that Florence went. For example, we don't know PR, but we've got a right angle triangle here, so we can figure it out. Or if we know our Pythagorean triples well enough, we know 17 kilometers here. So we can figure out the distance that Florence took to go from P to S. We'll know the time, because we were told that they arrive at S at the same time. So from there, we can figure out Florence's speed. And then, so we'll know both their speeds, and then we know the distance Florence went from P to R. We know the difference, the distance a Safa went from P to R. And we know their speeds, so we can figure out the differences in their times. Ooh, okay, so that's quite a game plan. Let's get to it. S, R, Q, P, 8, 15, 7. This is 17, and we can see this, by Pythagoras. PR squared is going to be PQ squared plus QR squared. 8 squared plus 15 squared, that's 64 plus 225. That's 289. PR is 17. Okay? Or you have that memorized. I know this one a lot. 8, 15, 17. It's sort of a weirder Pythagorean triple. It's not one a lot of people remember. Okay. So, what have we got? 8 plus 15 plus 7. A Safa goes 30 kilometers at 21 kilometers per hour. And this gives us a time of... So, time is distance over speed. So, 30 kilometers over 21 kilometers per hour. Both of these have a 3 in them, so that's 10 over 7 hours. Do I want to clean this up? Well, we might eventually want this in minutes, but I think 10 over 7 is fine. Now, they arrive at S at the same time. So, Florence... She goes 17 plus 7, 24 kilometers per hour in 10/7 of an hour. This gives us a speed of 24 kilometers per hour, or 24 kilometers divided by 10 over 7 hours is 7 times 24 is 168 divided by 10. 16.8 kilometers per hour, or 168 over 10, or I guess we could divide by 2. Let's keep it all as a fraction. So that'd be 84 over 5. Alright, so that's how fast Florence goes. 84 over 5 kilometers per hour, which is actually pretty close to 17 kilometers per hour. So if it was 85 kilometers per 5 hours, that would be 17. Okay, so now we want to know how long does it take them to get to R. Asafa gets to R. So Asafa goes 8 plus 15, 23 kilometers, and he's going at 21 kilometers per hour. So 23 over 21 hours is how long it takes Asafa to get to R. Florence gets to R in 17 kilometers, going at a speed of 84 over 5 kilometers per hour, and that'll be 85 over 84 hours. Just a little over an hour for Florence, but a little more over an hour for Asafa, and that's fine. We want to know the difference in their times. I'm going to get it in hours and then convert it into minutes. So the difference in times it takes them to get to R, 23 over 21 minus 85 over 84. Now, fortunately, 84 is a multiple of 21. So I can multiply top and bottom by 4. We'll get 92 over 84 minus 85 over 84. That's 7 over 84, or 1/12 of an hour. Well, 1/12 of an hour, and we convert that into 60 minutes per hour, is going to be 60 over 12, 5 minutes. So there's 5 minutes difference. Florence gets there 5 minutes ahead of Asafa. All right, so fairly calculation intensive, but once we had set up our plan and broke it down into chunks, it was really just how do we figure out speed if we know distance and time? How do we figure out time if we know distance and speed? And as long as we understand that, 21 is not particularly difficult. So 5 is going to be an answer of E. There we go, and I certainly don't think I'm going to get 23 to fit in this tiny space, so we'll do 23 on the next page in the next video. I'll see you there.